Here we are, Math 1, practice solving equations and inequalities. So, we're doing a lot of stuff with solving. Okay, these first ones we need to justify. So in order to justify, we need to understand those properties of equality we have. So if we look at this here, okay, here's our main properties of equality we use. We don't really use the reflexive or symmetric or transitive as much. The main ones we're looking at using is the addition, subtraction, multiplication, division properties of equality. Okay, those are the main ones we want to think about. We also will use some of these, but we don't really think of those as much either. But the commutative, associative, basically the order in addition and multiplication really doesn't matter. Okay, we'll use that distribution one quite often as well in solving our equations. So what we need to do here is we need to write on each of these kind of a T-chart here. So this is our given equation. So how do we solve it? Now remember, the keys in solving, okay, is we want to get the variable alone. Okay. To do that, we use those properties of equality to create equivalent equations. Okay. An equivalent equation is an equation that gives you the same answer but looks different. And we want to get the simplest equivalent equation possible. The simplest equivalent equation, I'll abbreviate equivalent equation, looks the same, is like x equals some number, okay, or a equals some number or something like that. That's our simplest equation that we want to get to, because we look at that and we know exactly what's happening, okay. So we're smart about it and we use those properties to help us get things simpler, okay, mainly these guys. Alright, so I look at my first one. I have x minus 5. To get x alone, I need to get rid of that minus 5. Well, how do I get rid of a negative 5 or a minus 5? We add 5 to it. So I'm going to add 5 to both sides. Now, why can I add 5 to both sides? Because of the addition property of equality. And I'm fine if you abbreviate, as long as you know what you're talking about. Because negative 5 plus 5 gives me 0. Okay. Negative 23 plus 5 gives me negative 18. Now, does adding 0 really do anything? No, and this is a rule that we don't really mess with a whole lot. But technically, I can eliminate that plus 0 because of what we call the additive identity property of 0. But I'm not requiring that one. I want to make sure you know how to do that one. Okay? Problem number 2, same idea. 26 equals a plus 19. I want to get a by itself, so I got to get rid of that plus 19. Well, how do we get rid of a plus 19? Well, we subtract 19. Okay, so that was my given. By subtracting 19, I have to maintain equality, I have to subtract from both using the subtraction property of equality. That becomes 0, but I just leave it off. So a equals 26 minus 19, which is 7. Now, some may say, well, then you make it a equals 7 using that symmetric property of equality. You can write that, but I really don't care. To me, that's the same answer. Okay? Now, number 3, we've got a divided by 3 equals 14 divided by 3. Well, how do we get rid of a divide by 3? This is given. We multiply both sides by 3 using the multiplication property of equality that allows us to do that. That says if I multiply the same thing to both sides, sorry about the bell, doing this during somebody's lunch that just ended. So if we multiply to both sides, we maintain equality. 3 over 3 becomes 1. 3 over 3 becomes 1. I'm left with a over 14. Now technically 3 over 3 is 1, so I have 1 times a. 1 times a and a are the same thing. The reason being, just like we have this additive identity, we have a multiplicative identity property of 1. But we don't really use that one. We don't think about that justification as much. Once again, I'm more concerned with these ones because they help us as we try to solve. Okay, now this last one. I've got a negative 10, x equals negative 150. So to get rid of that negative 10x, I'm going to have to do the opposite of multiplication. I'm going to have to divide. So I was given my first equation. So using the division property of equality, don't mistake that for a minus because I'm dividing. That becomes 1x. 1x we said doesn't really matter, so just x equals negative 150 divided by negative 10 is a positive 15. Okay? So there's all that you need to worry about with those ones. So let's take a look at the next four. Okay? So, once again, do this. You can write given already for the rest of these. Okay. So now on number 5, if I'm looking at this one, I have x plus 9 then divided by 15. Let's say for just example I knew what x was. Okay. If I knew what x was, what's going to happen first? Well, first it would be we'd add 9, then we'd divide 15, and it would be equal to 1. So if I'm trying to get x alone, I think about undoing that. So that divide by 15 is under the whole thing, so I need to get rid of that first. Well, how do we get rid of dividing by 15? We do the opposite. We times by 15. Why 15? Because that'll eliminate the 15. I'm left with x plus 9 equals 15. Why could I do that? Because of the multiplication property of equality. Okay? Now I'm not done, am I? Now I need to get rid of that 9. So to do that, I subtract 9. Okay? That gives me x plus 0, so just x equals 6. Why could I do that? Because of the subtraction property of equality. All right. Now, if we think about this, that multiplication, subtraction, addition, division property of equality means we can do anything. We can add, subtract, multiply, or divide anything. So if I look at number 6, could I start out by adding 100 to both sides? Yeah, of course I could. But that would give me a positive 76 equals positive 96 minus 2x. Okay, does that make my equation simpler? It's equivalent, it's still the same answer, but does it make it more simple? No, so why would I want to do that? I want to make it more simple, so I pick adding, subtracting, multiplying, or dividing numbers that will help it be more simple. So for this one, to get x by itself, we have to get rid of that negative 4. So I add 4. I choose adding 4 because that eliminates that one, leaves me with negative 2x equals negative 20. So the addition property of equality. Then we divide by negative 2 using the division property of equality. And I end up with 1, so just x, negative 20 divided by 2, positive 10. Okay, so I pick stuff that will help me out. Number 7, I want to get rid of that 1, so I subtract 1. So 0 minus 1 is negative 1, that's 0. So I have x divided by 12, so I use the subtraction property of equality. Then I times both sides by 12 using the multiplication property of equality. That becomes 1, so I'm left with x equals 12 times negative 1, negative 12. That equation is the same as that equation is the same as that equation. What's the simplest? This one. Because I look at it, I know exactly what 12 is. Okay, that's why we do it that way. So number 8, now this is where, so we look at this distributive property, okay, and realize that when we have something times by those, we can times each one separately. So that distributive, I'll just call it property of equality, means that 0 is equal to negative 7 times a, negative 7a, negative 7 times negative 2, positive 14. Then we subtract 14 from both sides, giving us negative 14 equals negative 7a, using the subtraction property of equality. Then we need to get rid of that negative 7, so we divide by negative 7 on both sides using the division property of equality, and we get a equals positive 2. And we're done. Alright, now on these ones, these next problems, we don't need to do the justifications, we're just solving here. But the same rules apply, we're still thinking along these lines. Okay? Trying to find what will help us create those equivalent equations that are more simple. Okay? Now, let me just use number 10 for an example for something. Okay, so we've got 3 equations here. In each of these equations, if I have the number 5, for x, they all work. These are equivalent equations. Okay, which one's the most simple and easiest to see what the variable is the last one. So that's what we're trying to get at, right? So in order to do this, we have a -6 and a +5 on the same side. If you have numbers on the same side, you can combine them if there's no variables. This x, we can't combine with them. So I get 4 equals x, -6 + 5 is -1. Okay, then I can use that addition property of equality to get 4 + 1 is 5. That's 0, so we're left with x. Okay, so jumping back to number 9. If we have 2 x's, we can combine them. So that's like -1 and -2, so it'd be -3x equals 24. We divide by -3, and we get -8 equals x. So let's just move on for these. So number 11, now we've got that distribution. So what I want to do is distribute, so 7 times 1 minus 7 times 3x equals 133. Then I simplify. 7 times 1 is 7. 7 times 3 is 21x. Subtract 7 from both sides, and that gives me 126 equals -21x. Divide by -21, and we get x equals a -6. Okay, number 12, we just keep doing it piece by piece. Start with the distribution to get rid of parentheses. 2 times 1 is 2. 2 times 8 is 16x plus 5x equals 170. 16x and 5x, I can combine those. Remember, 5x means we have x plus x plus x plus x plus x. And 16x means we have 16 of them. All being added together. So I can take them all and combine them, so 16 plus 5 would give me 21x. Can't combine the 2 because it doesn't have an x, so we subtract it to get the x by itself, because that's our goal, making equivalent equations along the way. And we get 21x equals 168, divide by 21, and we get x equals 8. Okay, so 13. Now I've got numbers and variables on both sides. So I can get rid of this 2n by adding 2n. That'll make it 0. Okay, but because of the addition property of equality, I do it to the other side. So 2n and 2n give me 4n plus 8 equals -12. Then I subtract the 8 to get rid of it. So we get 4n equals -12 minus 8 is -20. Divide by 4. We get n equals -5. For 14, I subtract an x from both sides. Now, x minus x is 0. X minus x on the right side is 0. So I'm left with -2 equals -2. Okay? Now, if you get rid of both your equations, there's 2 options. You either have no solution, or the solution is any number, so it's all reals. Okay? If it's equal and makes sense, -2 is equal to -2, it's all reals. If it were -2 is equal to +2 or something that didn't work, then it would be no solution. Okay, for ours, all real. All right, moving right along here now. Number 15 is -2x minus 32 equals 6 times 1 plus 6x. So leave the left side. I can't simplify it yet. We've got to simplify that. So 6 times 1 is 6. 6 times 6x, 36x. Now I can add a 2x. That becomes 0. We're left with -32. Remember, whenever you have a negative, a minus, it stays with the number. Okay, we get 6 plus 38x. Subtract 6 from both sides. We're left with 38x equals negative 38. Divide by 38. And we get negative 1 equals x. And number 16, our last one on this page. So once again, multiply. 5 times negative 8 is negative 40x. 5 times negative 8, negative 40. And I can do it differently. I could start by adding 40. Those would eliminate, leaving me negative 40x on the right. So negative 7x plus 66. Then we'd have to get rid of this 7x by adding it. So 66 would equal a negative 33x. Divide by negative 33. And we get a negative 2 equals x. Okay? So once again, on all of these, we created equivalent equations, used properties of equality to come with our simplest equivalent equation that was the easiest for us to see. Alright, now inequalities. Inequalities, we treat them the same way as equations. There's one difference. Well, I guess two differences. The first difference is an equation usually has one answer. Okay? An inequality is going to end up having more than one answer. It's something is less than or greater than the variable. So there's technically multiple answers, so we just write the answer like this and leave it. So that's one difference. The other difference is if we divide by a negative number or multiply by a negative number, we end up with, we have to change the inequality. The reason for that is because of this. If we think of the number line. Okay, let's think of this. We'll go 3x is greater than 3. Okay, so if I solved for x, I'd get x is greater than 1. So I would have a hollow circle, and then I would shade above that, right? Well, what if we change this to a negative 3x, and this changes to a negative? Now this positive 3 becomes a negative 1, so not only does it become smaller, like we did here, but it then takes this and throws it onto the opposite side of the 0 on the number line. Okay, and then instead of shading to the right, we end up shading to the left, which is not greater than, it's less than. So we have to match that change. And it's only when we multiply or divide by negative numbers, because if you divide by positive or multiply by positive, you're making the number bigger or smaller, but you're not going past the 0. Okay, it's when we go past the 0 that we run into issues. So let's see how it works. Alright, so 3 is less than or equal to negative 5 plus n over 2. First step, times both sides by 2. If we do it to both sides, we can. So we get 6 is less than or equal to negative 5 plus n. Add 5. We get 11 is less than or equal to n. Good enough. Okay, 18. We go the same route. We would add 7 to both sides just as if it were an equation. So 6n is greater than or equal to negative 42. Divide by 6. We get n is greater than or equal to negative 7. Now, some of you may say, well, we're dividing here and we have a negative, so don't we need to change this sign, the inequality sign? No, because the number we're actually dividing by is positive, not negative. Okay? It's only when the number we're dividing by right here is negative, not this one. Because this one was a negative, stays a negative. It's when it takes it from negative to positive or positive to negative that we have to flip the inequality. Okay, 19. We add 3 to both sides. Negative 3 plus 3 is 0. It's greater than 7x. Divide by 7. 0 divided by 7 is 0. 0 is greater than x. 20 times by 8. 8 times 1 is 8. It's less than negative 1 plus n because the 8's became 1. add 1 to both sides, and we get 9 is less than n. Okay? So most of these are treated just the same way as that equation. Okay? All right. Now we take a look at 21. So we would subtract a 10 from both sides. Okay, so that would be a negative 20 is greater than negative 10p. Now we're dividing by a negative. Okay, see the difference here? Now this number is negative. Doesn't matter what the top number is. It's this number that's negative. Because that becomes p, negative 20 divided by negative 10 is a positive 2. See how we changed from a negative up here to a positive? Because of that, we take our inequality and we just change it to the other direction. That's all we have to do. 22, we add 6 to both sides. Negative 8 plus 6 is negative 2. And divided by 9 times by n, or 9, we get negative 18 is greater than or equal to n. Notice here, a negative here, we times by positive, stays negative. Okay? Now, 23 and 24, we're dealing with literal equations, where we have lots of variables and we're not going to be able to get rid of the variable. So solving for x means we want x by itself. So just like as if n were a number, because the subtraction property of equality says we can subtract anything, I can subtract an m from both sides. M minus m is 0, leaving me 2x. Do I know what 3 minus m is? Nope. So I leave it 3 minus m. Then I divide everything by 2, and I get x equals 3 minus m divided by 2. Does that look much more simple? No. Making it more simple isn't necessarily the point on these ones. Okay? So 24, same idea, solve for x. So we subtract 2 this time. We get u minus 2 equals 2x. Divide by 2. And we get u minus 2 divided by 2 equals x. Okay? You could also make it u divided by 2 minus 2 divided by 2. And then you'd end up with u divided by 2 minus 1 equals x. Same thing. That's all we have to do for those ones. Alright, now we're going to take a look at our exponential equations. Alright, now remember, the idea here with the exponential equations is that we need to figure out 2 to what power is going to be 16. Okay? So the easiest way to attack this is just to go 2 times 2 times 2 until we get to 16. So 2 times 2 is 4, times by 2 again it's 8, times by 2 again, that gets us to 16. So 16 is the same as 2 to the 4th. So if 2 to the 4th equals 2 to the x, 4 has to equal x. Okay? So 26, we do the same thing. 5 to the x equals 15,625. So I start 5 times 5 is 25. Times that by 5, 125, times that by 5, 2. We get 625, times that by 5, we get 3125, times that by 5, and using a calculator helps out with this a lot. 5, 2, 10, 12, 5, 6, and 15. And there we go. So how many times did we multiply by 5? 1, 2, 3, 4, 5, 6. So 5 to the x would equal 5 to the 6th, which tells us x equals 6. Okay, 27, same idea. 3 times 3 is 9, times 3 is 27, times 3 is 81. So 1, 2, 3, 4. So 81 is 3 to the 4th equals 3 to the x, so 4 has to equal x. Okay, now 28, we have an issue here because now we have a fraction. The thing you have to remember is, like 4 to the x is 4 to the x. 4 to the negative x, if my exponent is negative, that's the same as 1 over 4 to the x. Okay? So probably the easiest way to think about it is to go, okay, well, 1 over 16 is like 16 to the negative 1. Okay? So 16 to the negative, so 4 to a negative power is going to get us what we need. Now, how can 4 become 16? Well, 4 times 4 is 16, so it's squared. So 4 to the negative 2 is going to be 1 over 16, so x has to be negative 2. Okay, 29, same idea. Okay, 1/7 to the x, that's like 7 to the negative x. So, to get 7 to be 49, that would be 7 squared, right? Would equal 49. So 1/7 would have to be a negative square to undo the fraction. So if it's not a fraction, that turns it to a fraction. If it's already a fraction, it turns it to not a fraction. It's kind of a weird rule. But basically, x has to equal negative 2 here. Okay, now on 30, right here we have the issue where 5 to the x it's not by itself. So sometimes the first step has to be getting the power by itself. So we get 5 to the x equals 131 minus 6 is 125. So if we go back here, remember, 2 5s was 25, 3 was 125. So it would be 3 5s. So 5 to the third would equal 125. So x equals 3. And there we go for these 30 problems. Just a bunch of different ways that we need to solve equations for a variable. And there we go.